Okay, now we will discuss the part 2 questions. Part 2 question. Take 2017, seventh question. 2017, seventh question. It is necessary to be vigilant and obey road rules when using highways. It is important for the driver as well as passengers to wear seat belts in the vehicle when traveling on highways. What is the reason for this? Yeah, this will also come under Newton's laws of motion. This is like I said earlier. Now, when the person is seated, what will happen? Now the vehicle will be moving, right? So, when the vehicle is moving, is under Newton's first law. Newton's first law. This is like I said earlier. Now, when the person is seated, when the person is seated, when the person is seated, the vehicle will be moving with a velocity, let's take 50 meters per second. 50 meter per second. When the vehicle is moving with a velocity of 50 meter per second, this person will also move with the same velocity 50 meter per second minus 1. So when brakes are suddenly applied, what will happen? This person will try to move in the forward direction. This person will try to move forward. When this person try to move forward, his seat belts the person is wearing will give him a force in the backward direction. Now, when the brakes are applied, the person will try to move forward. Now suppose when there is no seatbelt, what will happen? The person will break the windscreen and he will move out because there is no one to stop him from moving. When the vehicle is decelerating, when the vehicle from 50 meter per second come to 30 meter per second, then the vehicle is decelerating. It means the brakes are applied by the driver. When brakes are applied by the driver, what will happen? This person will try to come forward. When this person try to come forward, there is no one to stop him from moving forward. So this person will go in front. He will break all the dashboards. Windscreen will be broken. He will thrown out. What happened? So when the seat belts are worn, what will happen? When this person try to move forward, a force created by this seat belt, a force will be created by this seat belt for this person in the backward direction, and he will this seat belt will prevent the person from moving forward. This is the use of seat belt. So in highways, the vehicles are traveling at very high velocity. Suddenly, if brakes are applied, this is what will happen. Person will try to move forward. But this the use of the seat belt. This seat belt will create a force in the backward direction and prevent the person from moving forward. So here, write the explanation like this. When the vehicle is moving, the driver and the passengers have the same velocity of the vehicle. Therefore, to prevent the driver and the passengers moving forward upon applying brakes, the seat belts should be worn. Seat belt should be worn. what I said is given in the answer. Marking scheme, it's given the same way. And also it's given in the bracket, any answers with the idea of preventing the driver and the passenger from moving forward upon applying brakes. That is what is mainly happening. So what is the use of seatbelt? Prevent the passenger and driver from moving forward. That is the use of seatbelt. Yeah, for seventh one, first question. I have given the explanation. Answers are also given in the scheme. Check the answers in the scheme and write in your own words or write it in your own words. Try to give their answer in your own words. For this, they have given 1 mark. You should write all the key points. What are the key points? The passenger and the driver is moving with the same velocity of the vehicle. That is 1 point. Another point is brakes are applied. When brakes are applied, seatbelt prevent the passenger from moving forward. So the 2 key points. These 2 points should be in your answer. Now, Roman number 2. Roman number 2. Write down the Newton's laws of motion, which is connected to the answer you mentioned in one above. This is Newton's first law. You should write Newton's first law. Newton's first law. Now, how this Newton's first law is connected here? Now, in the book, there is a definition given, and also there's a definition in the sense the same thing is what I am saying in different way. What is the object in motion will be at motion until an unbalanced force is acting on it. Object at rest will remain at rest. Object in motion will be in motion until an unbalanced force is acting. So now if there is no seat belt, the person is initially moving with a uniform velocity of 50 meters per second. When the seat belt is not worn, what will happen? Unbalanced force will not be acted on that person. When unbalanced force is not acted on that person, the person will be in the same motion, will be in that same velocity 50 meters per second. The person will be thrown out of the windscreen with 50 meters per second minus 1. That is what is said. When no unbalanced force is acted, when seat belts are not worn, no unbalanced force is acted. The object at motion will be in that same motion. Okay, when the seat belt is worn, the object in motion will be, the unbalanced force. The seat belts will be creating an unbalanced force. The object in motion will not be in that same motion. He will not be at that same 50 meters per second. He will decelerate and he will come to the velocity of 30 meters per second. If the vehicle is moving 30 meters per second, the seat belt will give a force in the backward direction that will decelerate this person to 30 meters per second minus 1. So writing this, what's the marks given? Marks allocation. 2 marks given. 2 marks given. This can be explained by Newton's first law, or Newton's first law is also applied here. Newton's third law. Newton's third law is also applied here. How Newton's third law is applied? This person is giving a force to the seat belt. This person giving a force. Now, this person, he will be wearing a seat belt like this. He is giving a force like this. That seat belt is giving a force to this person in the backward direction. This person giving a force to the seat belt in the forward direction. An equal and opposite force is given to this person by the seat belt in the backward direction. Equal F and F, opposite in the forward direction, in the backward direction. Therefore, Newton's third law is also connected. They have given marks for either for this answer or for this answer. So the marks is 2. What is the second one? So the Roman number 3. Displacement time graph for the motion of the vehicle. This part is under motion in a straight line. This I didn't do under motion in a straight line because motion in a straight line is connected to these topics. Therefore, I thought of doing it under this one, under this topic. displacement time graph for the motion of vehicle A which traveled on an expressway from the beginning to the end at the maximum permissible velocity is given here. Here it has been assumed that the expressway is horizontal and it is in a straight line. Why they have said like this? Because in our syllabus we have motion in straight line. Now motion can be straight line in the sense it can be horizontal motion or it can be vertical motion. And there is something called projectile motion. Projectile means here I have a ball. I am going to project it with this velocity, not in the upward direction or not in the side, not in the horizontal direction. I am giving a force at an angle to the x. I am giving a force like this. So this will be moving like this. And this motion is known as projectile motion. This motion is not in O level, that is in A level. Therefore, they have said that the expressway is horizontal and this is moving in a straight line. In our syllabus, the questions are related to motion in a straight line pathway. Therefore, it is said that it is moving in a horizontal straight line. Okay. Now we'll see the time graph. See the graph given. Assume now what happens at this maximum velocity? Maximum permissible velocity. Now max for mem I put mn like this. Short term, remember it. Max EBM, right? For this short term is like this. For minimum also I will put like this. Min m like this. Maximum velocity means the object will move at constant velocity. Once it attains the maximum velocity, he will be moving with constant velocity. It's practical, right? Now, let us take a vehicle has the maximum velocity of 180 kilometers per hour. 180 kilometers per hour. If this vehicle is moving at 180 kilometers per hour, the speed cannot be increased further. He can't increase the speed of the car further. When the speed of the car cannot be increased further, velocity will not increase further. Therefore, that person will be moving at 180 km per hour. That is his maximum velocity. Remember, when they have given as maximum velocity, at their maximum velocity, the vehicle is moving with constant velocity. It is said that the person is from rest, his velocity is increasing and he attained the maximum permissible velocity. He is accelerating and reaching the maximum velocity. After that, he is moving with that constant velocity. That is what is known as maximum permissible velocity. Okay, these are some important points I am saying. Please note it down and highlight it. So we'll see the graph. With the graph, they have asked some questions. So, yeah, what is the length of the express pathway? That is a direct question. This 27,000 meters, right? Or 27 kilometers. Meters to kilometers, you should divide by 1000. So it's kilometers. So B part, calculate the maximum permissible velocity that a vehicle can be driven in this express pathway. You know, displacement time, gradient under displacement time graph. Gradient under displacement time graph is velocity. So the displacement is given. What is the displacement? 27,000. And what is the time? 1000. Remember, they have given in seconds, distance in meters. Therefore, velocity velocity is displacement divided by time, that is equal to 27,000 meters divided by 1000 meter, that is equal to 27 meter per second minus 1. That is the maximum velocity. You can give the answer like this, or you can say velocity is equal to gradient, and that is equal to 27,000 divided by 1000, that is equal to 22nd meter per second minus 1. For this, 1 mark. For B part, 2 marks. Now see the next question. In heavy rainy days, drivers are advised to maintain 15 meter per second as the maximum velocity for a vehicle that is driven on the expressway mentioned in Roman number 3 above. Now, in that vehicle, we have find out the maximum velocity. Maximum velocity is 27 meter per second minus 1. Therefore, it is advisable that the maximum velocity should be 15 meter per second. It is safe to travel at 15 meter per second, not beyond that. That is what is it. So they are asking what's the in A part, what is the main reason for advising the drivers not to drive the vehicle at a higher velocity when heavy rain exists. This is the everyone says like this, during rainy time you should drive slower. You should drive slower. Why? Because the road is slippery. Now during rain, the roughness of the road will decrease. The road will become smooth. Because of this rain, the road will become smooth. You know, the friction depends on nature of surface. Friction depends on nature of surface. So during rain, nature of surface is rough, smooth. When roughness of the surface increases, friction increases. When smoothness increases, friction reduces. During rainy time, during rain, the road will have less friction. Because of this less friction, the road will be slippery, and when you are moving at higher velocity and when you apply brakes, the vehicle will be skidding. It will not stop at that instant. Because of your higher velocity, the friction is less. The friction acting on the tires of the vehicle is less. When the friction reduces during rainy time, the the road will become slippery. Why the road is slippery? Because of less friction during rainy time. When there is less friction, then the vehicle will not stop at the instant you apply brakes. The vehicle will be skidding, and the probability of accidents increases during rainy time. This is the reason during rainy time the accidents increases. So, what should be the answer? Prevent the vehicle from slipping or prevent from accidents. Yeah, that's a simple answer, right? Sometimes you think deeply, but the answers will be simple. Now you see this. If you look at the, if you read the question, it's like difficult. But if you see the answer, this is simple. No, we could have written. No, you will think like that. Think simply. Think practical. Therefore, it will be easy. Now, what's the answer for this? In Roman number 4, Roman number 4, part A, answers given in the marking scheme. See the marking scheme and write it. Prevent the vehicle from slipping or prevent from accidents. What's the marks? 2 marks give. Sorry, 1 mark. Now see the B part. They have asked what is the physics behind this? Explain scientifically. Explain scientifically means you should try to apply the theory what you have studied. Now you say that the road is slippery. Now you should say why the road is slippery. You should give the answer scientifically. Now the science should be applied in this question. You should write what you have studied in the theory. You should apply what you have studied in the theory to answer B part. See the answer given. The possibility of accident is high due to reducing the friction or frictional force between the tires of the vehicle and the road when raining. When raining, frictional force reduces, therefore, possibility of accidents increases. So, what's the idea that you should have? Why the road is slippery? Why there is high accidents? Because the frictional force between the road and the tire reduces. It is not like normal days. During rainy days, frictional force reduces, therefore accidents increases. That should be the answer. Uh, yeah. During rainy time, frictional force between the tires of the vehicle and the road reduces. If you give the answer, that's correct. So the marks is 2. 2 marks is given. 2 marks. Before you see the class, please try to do the questions on your own. Now see, yeah, C part. On a heavy rainy day, the motion of vehicle B, which travel from the beginning to the end of the expressway mentioned in Roman number 3 above was as follows. Now that motion, the motion that we have discussed earlier is for vehicle A. Now another vehicle called vehicle B is traveling on the same express pathway. So the motion is explained in the paragraph. You see, C part. It started from rest and uniformly accelerated in the first and second and acquired maximum velocity 15 meter per second. What is this? Acquired maximum velocity 15 meter per second. It means once it attains the maximum velocity, for some time it will be moving with a uniform velocity. Thereafter, it traveled at the same velocity for a certain time, and in the last 10 seconds, it uniformly decelerated and came to rest at the end of the express pathway. Include the given information. Including the given information. Draw a rough sketch of velocity time graph for the motion of vehicle B. Okay, now I clean this. B part. What he is saying. Now, here we have vehicle B. This B. accelerated in the first 10 seconds, it goes with an acceleration. Initial velocity is 0 and then attain a velocity of 15 meter per second minus 1. After that, now this is for 10 seconds. After that, it is moving with that same velocity 15 meter per second minus 1 for time t. Let us take t1. T1. After that, last 10 seconds uniformly decelerated and came to rest. Velocity is 0 minus acceleration, that is deceleration in the last 10 seconds. This is the motion. To this motion, you should draw the graph. What graph? VT graph. In meter per second, minus 1, and t in seconds. You know, under VT graph, gradient is acceleration. Acceleration or deceleration. Here, the object is accelerating. How is it accelerating? Uniformly accelerating. If it is uniformly accelerating, uniform acceleration means uniform gradient. Uniform gradient. Therefore, uniform gradient. Gradient is same. Angle same. Gradient same. Theta, 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 theta. Angle same. For 1 second, 2 second, 2 second, 4 second, 6 second, 8 second, 10 second. For 10 seconds, gradient is constant and it attains a velocity of 15 meter per second. 15. If you put just 15, it's okay because meter per second is given in the y-axis. Now you don't need to put all this. I put this to explain. After that, it is being at uniform velocity for a time t1. I don't know the time. Now this is 10 seconds. This is for time t1. After that, it uniformly decelerate for 10 seconds. Uniform deceleration. Uniform deceleration. Gradient is constant. Uniform deceleration. From 15 to 0, it takes 10 seconds. This is the motion. This is the VT graph. Now, the important point when you draw graph. Here, in y-axis, you should mention V and also you should put a slash. You should put meter per second minus 1. In x-axis, you should put t, you should put a slash, you should put seconds. Now I need to put this 10 seconds. 10. And then you should put this also. They have given the value, no? So you should put the value. Maximum velocity is 15 meter per second minus 1. This is the graph. We will see the Marx allocation. See the Marx allocation. Naming the axis. Naming the axis, 1 mark. Shape of the graph, another mark. Marking, they have given marks for this, and for marking this as 10 seconds. How you should mark this? You should not put this arrow and all. Here, this is 10 seconds. 10 second. You should put because I don't know this time. Now let us take. It took t1 seconds to complete this motion, uniform velocity. Then here it should be 10 plus t1. Okay, and also it is said in the question. Now for this motion it took 10 seconds. Therefore here it should be 10. I am assuming now you should put now in the answer you should mark only this and then this. For marking 15 and 10 they have given another mark. Totally 3 marks are given for this graph. See the marks allocation. If you just draw the graph, you will lose 1 mark without marking the axis. Therefore, yeah. Now, first 10 seconds. Let's take the time taken for this motion is t1. Now, this is what you should write in the answer. And the scheme, this is the answer given. Now, let's take this. Took t1 seconds for this. Then here it should be 10 plus t1. For this, it took 10 seconds now. Therefore, here it should be 10 plus t1 plus 10. It means 20 plus t1. 20 plus t1. That's it. So 3 marks are given. Yeah, we'll move to the next question. Find the total time taken by vehicle B to travel on the expressway. To travel on the expressway. This is the tricky part. Most of them will not do this question. Now you know the total displacement. How do you know the total displacement? It is given in previous question. It is said the vehicle A travels a displacement of 27,000 meters. In this question, it is said the same vehicle B is traveling on the same express pathway. The pathway that he's traveled is also traveled by him. Same express pathway is 27,000 meters. Therefore, his displacement is 27,000 meters. The displacement of B is also 27,000 meters. It means you know the area under VT graph. Area under VT graph is displacement. Therefore, what's the area? It's trapezium. Area is equal to half into A plus B into H. What's the total area? That's the displacement, 27,000 meters. Half into, what is this? 10 plus 10 plus T1. That is 20 plus T1. 20 plus T1 and half into A plus, what is this? That is T1. T1 into, that is 15. How are you going to solve this? Okay, let me take this 2 to the top. 27,000 into 2 is equal to 20 plus 2T1 into 15. Let us take this 15 down. 20 plus 2T1 is equal to 27,000 divided by 15 into 2. In 15, how many 3's are there? 5. In 27,000, how many 3's are there? 9. Therefore, yeah, in 90, how many fives are there? In 90, how many fives? 18, right? Yes. Therefore, 1, 18. 20 plus 2t1 is equal to 1800 into 2. Therefore, 2t1 1800 into 2 minus 20. And this t1 is equal to, I will take this 2 down, 1800 into 2 minus 20 divided by 2. If you solve this, you will get the answer. 1800 into 2, 18, 36, 3600. 3600 minus 20, 3580 by 2. What's the time? T1 is equal to 1790. Therefore, you will get T1 is equal to, how to write it? 1790 seconds is T1. So what they have asked, the time taken for the total motion. The total motion is 1790 T1 plus 10 plus 10. 10 plus 10, that is equal to 1810 seconds. That's the answer. Okay, note it down. What's the next question? Momentum when the object is moving with constant velocity of 15 meter per second. You know, momentum is equal to mass into velocity. That is, P is equal to mv. P is equal to mass they have given us 3000 kilogram into velocity 15 meter per second. What's the mass? Is it 3,000 kilogram? Mass, yeah, 3000 kilo. Therefore, 15 into 3 is 45. 45 at these three zeros. 45,000. Unit is important. They give marks for unit. Kilogram, meter per second, minus 1. That's it. 2017 done. 2017, yeah, 2017 done. We'll move the next question.